This is section 2.5 and 3.1, linear functions and models. So hopefully we can go through this kind of quickly as it is a review from Algebra 1. So for the first example, it's given to you in slope-intercept form. The first thing you do to graph it is plot the y-intercept, which is at -1. And then you rise 2 and go to the right 3. And so we can draw a straight line through those 2 points Okay, so in slope-intercept form, we have the y-intercept, which is your b value, which is 0, -1. And then, like I said, we graph with our slope, which was 2/3, which is our rise over our run. Okay, so if you're given the equation in standard form, then you graph it with your x and y intercepts. So at the bottom here, your x-intercept is when y equals 0. So I'm going to take the function above and plug 0 in where there's a y. So I have 2x minus 3 times 0 equal to 3. Therefore, 2x equals 3, and x equals 3 halves, or 1.5. And then my y-intercept, I'm going to plug 0 in for x and have 2 times 0 minus 3y equals 3. Negative 3y equals 3. So y equals -1. So I take these two values. So at x I have 1.5, 0. And for y I have -1, 0. So then I connect the two and I have my line. And then if you were given a graph in point-slope form, you are given a point on the line and you are given the slope, hence the name point-slope form. So the point that we were given in that above equation comes from the y1, x1. So x1 says -3, or I'm sorry, it says +3, but it's always the opposite. So we have -3, +3. Or I'm sorry, -3. Because this is the formula right here, it's in terms of the minus sign. So if you have two positive signs, the only way you can have y +3 and x +3 is if you had y minus -3 and x minus -3. So that's our point. Our slope is that m value in that position, which is 2/3, which is your rise over your run. So I'm going to first plot the point very similarly to slope-intercept, but I have a point at -3, -3. And then I'm going to do rise over run. So I'm going to rise 2, go over 3. So essentially what we just did was we graphed the same equation, but in 3 different forms. Okay, so now we're going to review a little bit of slope. So some specifics with slope. If I have positive slope, the line looks like this. That means that I have the y values that increase. As my x values increase. And then I'm going to add from left to right. And an example of this is if I had y equals 2x, my slope is 2 and it's positive. Negative slope is the opposite. My y values decrease from left to right. So when I write an equation, I can have y equals -2x, and I have a -2 slope. Okay, if I have a 0 slope, that means it's a horizontal line. That means it's y equals a number. If it crosses through the y-axis, we say y equals. And it's always going to be set equal to y equals. So an example would be y equals any number, and I'm just going to pick 5. If you have undefined slope, this is a vertical line. This is going to be an x equals, because if it's vertical, then it cuts through the x-axis. So it's always going to be x equals any number. So my example of this is going to be x equal 3. Okay, so parallel lines. So if we say, okay, so let's say we have for line 1 and for line 2, dot, 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 if m, which is the slope of line 1, is equal to the slope of line 2, then line 1 is parallel, that's the symbol for it, line 2. Basically, I'm saying parallel lines have the same slope. So, for the same two lines, if m1 times m2 equals -1, so if I divided both sides by m2, if m1 is equal to -1 over m2. Now this is very fancy for saying that m1 and m2 are opposite, meaning the opposite sign, positive or negative, reciprocals. So I know you remember this, but what I wrote over on the left is just the notation for it. And then I'm going to add, then we say that line 1 is perpendicular to line 2. Alright, so there is one exception. Those are vertical lines and horizontal lines. So obviously knowing that a vertical line is perpendicular, meaning it forms a right angle, with a horizontal line, yes, those are perpendicular lines. However, mathematically, this a little above formula up here doesn't work because you can't deal with it because vertical lines have undefined slope and horizontal lines have 0. So that what I wrote in purple doesn't really apply, but logically you need to know that vertical lines and horizontal lines are perpendicular to one another. Okay, so if I gave you the words, the linear function g of x has a rate of change of -7 and an initial value of 1, we're going to write that equation that looks like g of x is equal to -7, because that's the rate of change, that's the slope, plus 1, which is my initial value. So mx plus b is what I'm working with here. So if we created a table, and let's say I use -2, -1, 0, 1, and 2. When I plug them in, I get 15, 8, 1, -6, and -13. And when I say plug them in, I mean to this equation we just wrote. So when I graph this, I'm going to go up to 1 and put my y-intercept. I'm going to go down 7, 1, 2, 3, 4, 5, 6, 7, and over 1. right here. To fit in one more point, if I needed that, then I would change, well, that was a bad line. I would change the scale, but 2 dots are fine because 2 dots make a line. Okay, so based off of this table, we then need to figure out the words and then figure out the equation and then graph it. So looking at the table, the first thing that I notice is that the difference between 5 and 2 is -3. 2 and -1 is -3. So continuing this trend, continuing the table, I have -4 and -7. So I could graph that all right now. -2, 1, 2, 3, 4, 5. -1, 2, 0, -1, 1, 1, 2, 3, -4, and then 7, 2, 7. All right, so here's my line. So if I took this graph, the y-intercept is 1, and my slope is -3, so I have y equals -3x minus 1. So in words, I would say the linear function y has a rate of change of -3 and an initial value of -1. Okay, so finding the equation of a line. So we're going to find the equation of a line that has a slope of 3 and passes through this point. So the easiest thing to do, since I'm given a point and the slope, is to use point-slope form. So that's going to look like this. Y minus y1 equal to the slope times x minus x1. So I have y minus -7 is my y value of the point, equal to 3, that's my slope, and then x minus -3, that's that x value of that point that I have. So when you simplify this, we have y plus 7 equal to 3 times x plus 3. Now, I'm going to ask that you write this in, or always convert it to y equals mx plus b form, slope-intercept form. So when you do that, we are going to distribute 3x plus 9, and then we are going to subtract 7, so I get y equals 3x plus 2. Okay, so find the equation of a line that is parallel to this given line and passes through the point -2, 5. Another disclaimer, you need to know, I don't care what method you use to start any of these, but you need to know them all. But I do usually put them back into slope-intercept form. But again, on tests and quizzes or whatever, read the directions and give me what I'm asking for. Okay, so what I would do first is say, well, I need to identify the slope because I know I need to work with a parallel line. So if it's parallel to x plus y, I'm going to subtract x and say y equals -x plus 2. So the slope of this line is -1. So if I want it to be parallel, then my new line is also going to have a slope of -1 because parallel lines have the same slope. Now, I have a point that was given to me, so I'm going to borrow it to solve for the new, the y-intercept, the b value. So if I'm going to use y equals mx plus b, So this is my x and my y I'm going to borrow. 5 equals negative 1, since it's parallel, times x, which is negative 2, plus b. Subtract 2, and b equals 3. So my answer is y equals negative 1x plus 3. Okay, so it says find the equation of a line that passes through negative 1, 1 and is perpendicular to the line through those 2 points. So the first thing we need to do is find the slope of these 2 points and then be able to do the opposite reciprocal of it. So that's 2 minus 1 over 2 minus negative 1, which gives me 1/3. So therefore, since it's perpendicular, the slope of the line that I'm going to finish with is the opposite of that. So it's going to be negative. And the reciprocal of 1/3 is 3. So this is the slope that I'm going to have in my final answer. So once again, it has to go through negative 1, 1. I'm going to borrow this x and this y value. 1 equals negative 3 times negative 1 plus b. 1 equals 3 plus b. So b equals negative 2, giving me a final equation of y equals negative 3x minus 2. Okay, so this last one here says find the equation of a line that passes through 2, 2 and is perpendicular to y equals 4. Well, the first thing that needs to point out to you is that y equals 4 is a horizontal line. So let's graph it. If it's a horizontal line at y equals 4, it's right there. But it passes through 2, 2, so that's this point right here. Well, if it's perpendicular to that, it has to be a vertical line. So what's the equation of this vertical line then? Because it passes through the point and it's perpendicular to y equals 4. So my answer is x equals 2. All right, the last thing today is the parabola below depicts negative x squared minus 4x. A secant line to the graph is shown, like we've talked about before, and passes through those 2 given points. So I'm going to label that. This point right here is negative 3, 3. And down here at the bottom, we have 1, negative 5. Given that the line is parallel to the secant line, so there's a line parallel to this, but passes through the point negative 1, 3. So it's going to pass through this point right here. Well, this is just another way of asking what we've been working with. So the slope of the line, of the secant line, we need to find. So let's say we have y2, which is negative 5, minus y1, which is 3, all over x2, which is 1, minus x1, which is negative 3, which gives me a slope of negative 8 over 4, which is negative 2. Now it's parallel, so this works for us. This is going to be our final answer. So if it passes through the point negative 1, 3, again, I can borrow that. Or let's work, I don't know, with point slope form, something different. Y minus 3 equals to negative 2 times x minus negative 1, which is plus 1. Again, I'm just choosing something different. And when I simplify, I'm left with negative 2x as my slope plus 1. So that would be right here. Which gives me a line sort of looking parallel to the secant line that was given.